Hello everyone. In this video we are going to create a simple 2.5D platformer game prototype using Panda3D and Python. The end result will look like this. As you can see, this is just a very basic game. The character just falls down at the beginning and it stops when it collides with the floor. So I'm just going to show you again. So it starts here and it falls down. We can move the character left and right by pressing the left and the right arrows, and also jump by pressing the up arrow. And if I press the up arrow when he is jumping, or it is jumping, we can perform double jump. The character has some acceleration when we press the right or the left key, and also has deceleration when we release the keys. So it doesn't start to move at its full speed, but it quickly accelerates to its full speed. And also when we release the keys, it doesn't stop immediately, but it quickly decelerates until it stops. So as you can see now, when I press the right arrow, it just accelerates, and when I release the arrow, it decelerates until it stops. For these things, for the velocity, acceleration, position, we are going to use 3D vectors. The character can jump through the platforms and also land on top of these platforms, so we are going to also implement these collision detections with the platforms. There are still some bugs, so if I move quickly, it just moves to this higher platform, but if I move slowly, it falls down. So as I say, this will be just a very basic platformer prototype game. You can also one thing what we are going to implement also is the camera follow, so the camera will follow the character. One more thing, you can find the timestamps in the video description so that you can navigate between the sections if you want. And at the end of this video, I'm also going to ask you to help me to solve a little problem I couldn't get my head around. But first of all, let's just start to create the game template. So before I start the coding part, I'm just going to show you how I created the 3D assets, so the 3 platforms, the floor, and also the character. So for this, I have used Blender 2.8 because the egg exporter only works with Blender 2.8. It doesn't work, or at least I don't know if it works with 2.9, Blender 2.9. So I just created here the floor, the 3 platforms. I'm just selected all of these, the 3 floors and the 3 platforms and the floor, and just exported it out as a Panda3D egg. Then I'm selected the character, which is this geometry, and I exported it out as a Panda3D egg file format. So okay, so if you want to have the same egg exporter for Blender 2.8, you have to go to the GitHub, and I'm going to add this link to the video description. So the guy who is creating the egg exporter is called Kergalim, and the egg exporter is called PRPEE. So as I said, I'm going to add this link to the video description so you don't have to search for it. And here it says that it is an egg exporter for Blender 2.8 and Panda3D with render pipeline. And this is version 1.0, and it can export meshes, UV layers, materials, vertex colors, textures like diffuse, normal, roughness, armatures, skeleton animations, shape key, morph animations, and non-cyclic NURB curves. So you have to download these these files and just install it in Blender. So you will have the export option here after you install. So I already prepared the files, so I'm just going to use this platformer.py file, Python file, and I'm also copied the egg files to this. I have here a main folder called platformer, and under this folder I have a second subfolder which is called egg-models, and in the egg-models I have the floor.egg and the player.egg. The floor contains the floor and also the platforms, and the player only contains the player geometry. And okay, so let's create a basic Panda3D windows. So for that I'm just going to import the following. So from direct.showbase import the showbase class, and this is the base for all Panda3D applications. The next thing I'm just going to, just to save time, I'm going to just copy and paste code from my second monitor. So I'm just going to create a my game, although I'm just going to rename it to platformer. So platformer class, which inherits from the showbase class. And then we are calling the init method of the platformer. And in the init method of the platformer, we are just calling the showbase's init method. So it will initialize all the showbase's variables and methods and so on. And here I'm also setting the background color of the window to pure black. So red, green, blue, and 1 for alpha. The next thing will be just to create an instance of the game. So game equals platformer, and then on the instance game I'm just going to call the run method, which will enter the game.run, which will enter the so-called game loop or the application loop. So with these few lines, if I right click and run it, we have just created a basic Panda3D window. And okay, I'm just going to close it. So the next thing I'm just going to do is just setting some configurations. So for this I'm just going to import one more function from panda3d.core, import the load prc file data. And I'm just going to create here a Python multi-line string called config vars or config variables, and here I'm going to set the win-size or the Windows size to 1280 by 720, so the width and the height. And I'm also going to set the show frame rate meter to 1. I already explained many of these things in my Panda3D tutorial, so I'm just going to briefly go through this in this one video. And the next thing will be just calling this load prc file data, which has the first argument an arbitrary name, which can be an empty string, and the second argument is the config variables. So this load prc file data will read these settings here. So it will set the Windows to 1280 by 720, and it will also show in the upper right corner of the window the frame rate meter. So now if I run it, now as you can see I have a window with 1280 and 720, and in the upper right corner it shows the frame rate meter. So my in my game it runs on 60 FPS, so this is synchronized with the monitor's refresh rate. In this section I'm just going to load the two models, the player.egg and the floor.egg. So let's start with the player, and as usual I'm just going to copy and paste the code because I'm typing very slowly. So here with this line, self.player will be equal to self.loader.load model, and give it the path to the model. So it is in the egg-models folder, and it's called player.egg. And as I said earlier, we don't have to add the .egg extension. So now we are loaded the player model. We are also going to reparent the player to the render. So it is added to the scene graph and it will be visible in the window. So let me run it. And now the player character is in the same position as the camera, so I have to move the camera with the right mouse button back a little bit. And okay, so as you can see, here is the player character. Now let's load also the floor, and the floor will be self.floor equals self.loader.load model from the egg-models folder, so from this folder, and it's called the floor.egg. And also reparent the floor geometry to the self.renderer, so it will be visible. So now let's run it, move the camera back, and as you can see, now we have the floor, the three platforms, and the player character. And as I said earlier, this floor.egg file contains not just the floor but also the platforms. Okay, one more thing is that I'm just going to move the camera a little bit. So if I run, as you can see, I always have to move the camera back. So I'm just going to move the camera on the y-axis, which is the forward and backward axis. And also I'm going to move the camera on the z-axis, which is the up and down axis, so that I don't have to move always with the mouse. So here, after set background color, I'm just going to add one more line, self.cam.set position x0 on the y, which is, as I said, is the forward and backward axis. I'm going to move it -65 units back. And on the z-axis, which is the up and down, I'm just going to move it a little bit up. So now, if I run the application, now I'm seeing the scene from this upper angle. In this section, we are going to set up a very basic point light and also ambient light, so that our scene is not so now it is just this flat shaded, and to make it a little bit more interesting, we are going to create a point light and also an ambient light. So for this, I'm just going to create a second file inside the platformer directory or folder, and I'm just going Python file I'm just going to name it light setup, light_setup. Okay, yes, I want to add it to the Git, and in this light setup, I'm just going to import two classes from Panda3D core. So from Panda3D core, import the point light and also the ambient light. So I'm just going to copy a function here called setup point light, and this function takes two parameters. One is the renderer and the second is the light's position. So here in the function's body, I'm creating a p light from the point light, we import it here, and just call it p light. I'm setting the point light's color to pure white, so 1, 1, 1, 1, so red, green, blue, and alpha. Here in this line, I'm creating a new notepad, PLNP or point light notepad, using the render that attach new node. So this will return, when we call the render that attach new node function, this will return a point light notepad. And to this attach new node, we are adding the point light node. So we created here. Here I'm setting its position, or the point light notepad position, using the set position, and here I'm giving the position 0, position 1, and position at index 2. So this will be a 3D vector. And here I'm just setting the renderer's set light, using the renderer's set light method, the point light notepad. So it's a little bit complicated, but this is how Panda works. So I'm just going to import this file into the platformer.py. So from light setup module, import the setup point light function, so this function. And here in the init method, I'm just going to call this function. And I'm also just going to copy this from my second monitor. So I'm added here the command set up the lights. So set up point light function, and as I said, it takes as a first argument the cell.renderer. So here we are using, where it is. So here we are setting the renderer's light to PLNP, or the point light notepad, and its position as a tuple. So 15 on X, 0 on the Y axis, and 20 on the Z axis. So here we are setting this by indexing the tuple. So now if I run it, now we have a basic point light. So the light comes from 15, 0, 20, so 15 to the right, 0 on the Y, and 20 on the Z-axis, which is the up and down. So the light is somewhere here, comes from the upper right corner. And I'm also going to add some ambient lighting, so that these sides of the platforms, and also the floor, and also the character, are not that dark. So if I move the mouse, as you can see now, these are totally dark. So I'm just going to add a little bit of ambient lighting to this. And yep, so copy from my second monitor and paste it here to the setup point light function. So here I'm creating an A light, or ambient light, using the ambient light we imported here, and just calling it A light. Setting the ambient light's color to 0.08, 0.08, and 0.08, so red, green, blue, and 1 for the alpha. And don't forget that you have to set it as a tuple, and the same here. So P light, that set color as a tuple. And here I'm just creating an ambient light notepad, the same as here, using the render that attach new node and attaching the A light, or the ambient light node. So remember, in my Panda Basics series, I already talked about the nodes and the notepads in Panda3D, and you can also just search in the documentation if you want to know more. So the renderer that attach new node, it will attach a new node to the renderer, and from this in this method, or this function, we return a node path, and we are saving this to this variable, and we are just setting the set light with the set light method, renderer that set light the ALNP. So now we are going to have also an ambient light. So now, as you can see, if I'm just going to move it a little bit closer, now these sides are not completely dark or completely black. All these sides also on the platform, also on the character, and also the floor have some basic ambient lighting. And now comes the movement part. So I'm just gradually going to create all the movement. First, in the first part, I'm just going to make the character move left and right. And then I'm just going to add the acceleration and deceleration, and also later I'm going to add the jumping and lastly the collisions. So how to make this character move? First of all, we need some keyboard input events, and I already showed it, I think, in my Panda3D tutorial series, how to add movement using the keyboard. So I'm just going to create a global key map here in the platformer.py after I loaded the PRC file data. And this will be a Python dictionary, and it will have two keys. One is the left and one is the right, and this will be booleans, so both will start with false. So the left will be false and the right will be false. The second thing, I'm just going to add a very simple function, global function, although this can be also a method inside the platformer class, but it doesn't matter. I'm just decided that I'm just going to use it this way as a global function. So this will take two arguments, the control name and its state. And the control name will point to the left, and the state will be the true or the false. And yeah. And in the key map, which is this global dictionary, I'm just going to change the control name, as I said, which will be either the left or the right key, and the state will be the false or the true. So, and now we have to add in the platformer, we have to add under this line, I'm just going to add 4 lines. So using the self.accept method, I'm going to accept the arrow left. When we press the arrow left key, it will call the update key map function, so this global function. And this will be passed as arguments to this function. So the left will be passed as a control name, and the true will be passed as the state. So when we release the arrow of left, so when the event is arrow underscore left dash up, we will call the update key map. The left key will be set back to false. So when we press the left key, this state will be set to true. When we release the left key, the state will be set. So here on the key map, the state will be set back to false. So, and the same applies to the right. So when we press the right arrow, we will call the update key map function, and which will set the right to true. So the right in the key map will be set to true. And when we release the right arrow, so arrow underscore right dash up, event is happening, we will call once again the update key map, and we set, using this function, we will set the right back to false. So it will call this function, and this function will change this key map based on which key is pressed or released. So left, if the left is pressed, it will set this to true. If the left is released, it will set back to false, and the same applies for the right key. And okay, the arrow up, so the jumping, I'm just going to add it a little bit later. And we need also a few more things. So we are just going to create here an update method, in the platformer class. So def update and for now I'm just going to pass it. And it also needs, the update method also needs, because this will be added to the task manager, it also needs a second argument called the task. And now we are going to add this update method to the task manager, so it will be called in every frame, so 60 times in a second. And we can do this by calling or adding this command. So self.taskmanager.add the self.update. This is this method, and this is just the name of the method update. You can name it whatever you want, but I'm just calling it update. So now that we are added this update method to the task manager, this update method will be called every frame, as I said, 60 frames in a second. So I'm just going to print out something like hello, and if I run it, oops, one more thing, if we want to first of all, this task manager only runs the update method only once, because we have still to return something from this update method. So when the update method finishes, we will return the task.count. So this will ensure that this update method gets called in the next frame. So now if I run it, as you can see now, it prints out hello 60 times in a second. So I'm just going to remove this print. So in this update method, I'm just going to add all the movement logic. So in this section, we are going to add the movement vectors and also some constants like the speed, the gravity, and friction and jump force. So after this line, I'm just going to copy 3 lines, and we also have to import the vector free from Panda3D core. So here we are already importing the load PRC file data, so I'm just going to add the comma and also import the vec free class, vector free. So first I'm creating a position vector, so the player's initial position will be in the air. So here I added this comment, this is also the initial position of the player, so it will fall down at the beginning of the game. Here I'm created a velocity vector with 0, 0, 0, so x, y, z, and also an acceleration vector. Now let's create some constants, and I'm just going to copy these. So the constants will be the self.speed, which will be set to 4, the self.gravity, which will be set to negative 0.05, the self.jump force, although we don't need yet the jump force, but we are going to use it later when we are going to implement the jumping, and also the self.friction, which will be set to negative 0.12, and this has to be a negative number, don't forget. So now that we have the vectors, the movement vectors, and also the constant, in the update method, I'm just going to call one more line, or set one more local variable local to this function or method, which will get the delta time. So dt equals global clock.get dt. So this will return the delta time. So the delta time is the time since the last frame, time passed since the last frame. So usually the application runs at 60 frames per second. So the time can be, so if the application runs at 60 frames per second, the delta time will be 1 divided by 60, which is 0.01666666 repeating. So this dt, or the delta time, will be this value 0.01666666. And this is needed so that on slower computers or faster computers, the character will move with the same speed. Doesn't matter if the application runs slower or faster. The character's speed will be always the same. So okay, now the next thing I'm just going to set here two if condition. I'm just going to copy here two if conditions. So if keymap, which is this global dictionary, if keymap right is true, so when we press the right arrow, the keymap right key will be set to true, remember. And so if this is true, we are going to set on the self.acceleration.x, so on the x-axis, where we are going to set it to self.speed, which is 4 times the delta time. If the keymap is left, so the left key is pressed, we are going to set on the acceleration.x to negative speed times the delta time. And after this line, I'm just going to copy one more. So we are going to set the self.acceleration.x plus equals the self.velocity.x times the self.friction. So the friction is set to negative 0.12. So, and we are going to only add friction to the horizontal movement. The next thing is setting the velocity in each frame. So the velocity will be plus equals the self.acceleration. So we can add and subtract and multiply vectors. And when we do this self.velocity plus equals self.acceleration, it will do element-wise. So the velocity x will be, to the velocity x will be added the acceleration x. To the velocity y will be added the acceleration y, and so on. So the velocity z, to the velocity z will be added the acceleration z. So don't forget that these are 3D vectors. And the last line, we are just going to set the position, so self.position, which is also a 3D vector. So the self.position plus equals the self.velocity times the self.acceleration times 0.5. And the last thing here, we are just going to set the player's position, so self.player, the set position to self.position. So remember, the player is this notepad. We are already represented this to the renderer. And now let's take a look if it works or not. So now the player starts here because we have set the initial position to 0, 0 and 30. So 30 is the up and down axis. And let's try to move it. So I'm just going to press the right arrow. And now it does this strange thing. I'm just going to move the character a little bit down. So let's start it, I don't know, 50 on the Z, or 15 on the Z. So we still missing one more line. We have to reset in every frame the acceleration vector, so that it doesn't does this thing. And we can do this by after we are getting the delta time, we are just going to reset the acceleration. So self.acceleration will be equal to vector 3, and for now I'm just going to set it to 0, 0, 0 on all 3 axes. And now let's try to move it. And now, as you see, it works. So if let me show you. If I now press the right arrow, just watch how the character accelerates to its full speed, and when I release the right arrow, it doesn't stop immediately, it decelerates until it stops. So pressing the left key accelerates, releasing decelerates, so it still moves some units to the left or right until I release the arrow keys. And this is all done by these 3 lines. I'm just searched how movement works in real life, and I found some Wikipedia articles and also some YouTube videos how to add realistic character movement to your game characters. So this is how you can do this in Panda3D. Okay, so now add back the gravity to the self.acceleration in each frame. So remember that the up and down axis is the z-axis in Panda. So here vector 3, 0, 0, and we are going to set the z to self.gravity. And now each frame the character will be pulled down by the gravity in each frame, so it will just fall through everything. And I'm just going to move back the player character initial position to 30 on the z-axis, and let me run it again, and it just falls through the platform. So in the next part we are just going to add some collision detection, so that when it hits the floor it will stop. So as I say, the gravity always acts, so it always works, so it never stops working on the character. Okay, now we are going to implement the collision detections. Okay, so let's start to implement collision detections. So until now we have this, so the character just falls through the floor and also through the platforms. So if you want to learn more about the collision detections, you should go to panda3d.org, go to the manual, and here in the programming with Panda3D, click on this, and here you will find the collision detection section. And here you will find the documentation about the collision solids, and also the collision handlers, and also the collision traversers. We are going to use the collision handler queue, the collision traverser, and also the collision box. Okay, so let's go back to the code. And for this we will need to import from the Panda3D core some classes. So I'm just going to copy from my second monitor, and here after this line I'm going to import the following. So from panda3d.core import the collision box, the collision traverser, the collision handler queue, the collision node, and the bitmask 32. So these classes we are going to need. Okay, so here in the init method, platformers init method, I'm going to, after this line, I'm going to implement the necessary code. So the first thing what we need is just create a collision traverser object. So we imported this class here, collision traverser. So now that we created the collision traverser object, or instantiated a collision traverser object, the next thing what we have to create is the collision handler queue. So I'm just going to copy it here. I'm going to name it self.queue, which will be equal to collision handler queue. And one more information, the collision traverser object should be named like this. So ctrav with the capital T, otherwise it won't work. So the next thing, we are going to create a collider node or collision node. So I'm just going to name it collider node using the collision node, and I'm just going to give a name box dash col or collider, and this is a collision node for the player. Okay, now let's create the collision box, and this will be the actual geometry. So collision box will be equal to collision box class we imported from the Panda3D core. So the collision box, and these are the dimensions of the box. So I'm just going to show you how it looks like later a little bit. The next thing I'm just going to do is to the collider node I'm going to add the solid collision box. So to the collider node, which is this collision node, I'm going to add this collision box solid on this line. Okay, now let's create a collider, and the collider will be equal to the self.player.attach new node and the collider node. And I know this is a little bit complicated, but this is how Panda works. And the last thing is just adding to the collision traverser object. So using the self.collisiontraverser.addCollider method, adding it to the collider node we created here on this line, and also the self.queue, so the collision queue. And lastly, what I'm going to do is just show the collision box around the player. So without this, the collision still not works. I'm just going to, for a second, I'm just going to set the gravity back to 0 and also move the player's position to, let's say, 8. So now it just levitates here in this position. So to actually see the collision box around the player, we can do here, after this line, I'm just going to copy one more line, which is collider.show. So the collider is this node. And now it shows the collision box around the player. So this is where the player will collide with this box. And these box dimensions are given here. So let me see. So if I give it 1, 1, and instead of 4, I'm also will give it here 1. Now, as you can see, the collision box is much lower. So I like when the collision box covers the whole character. So that's why I gave here 1, 1, and 4 for the z-axis. So this is XYZ, the first point, and this is the second point, XYZ coordinates. And from these points, this class, collision box class, constructs this box from these 2 points. And if you want to learn more about the collision box, you can go to the documentation, open up the collision box, and here you can see that the first arguments, the first point are the center point, or here also the min x, min y, and min z, and the second is the max x, max y, and the max z points, or the maximum z points. Okay, so now we have a collision box. Okay, now we should implement the collision detection inside the update method. Okay, and here after these lines, before I'm setting the position of the player, I'm just going to add an if condition. So if self.queue that get entries, this get entries from the queue, the collision queue, this should return a list of entries, collision entries. And if this list is empty, then this else part will be executed. And if there is a collision, then this part will be executed. So it will print out collision. And when there is no collision, it will print out no collision. So let me try it. So now, as you can see, it continuously prints here on the console that collision, collision, collision. And this is because the box collides with the player geometry. We want to disable the collision detection for this box with the player geometry. And for this, we are going to use the bit masking. So that's why I imported here the bitmask32 class. And when we create the player, I'm just going to add one more line. So self.player.find the player, get the node, and set the into collide mask to bitmask32.bit2. Yes, I know it's a little bit complicated, but as I say, this is how Panda works. And if you want to learn more, just read through the documentation or search for another tutorials. I will be honest, I still don't understand it 100%, this how it works, so I'm just testing it and with a trial and error. So now it still should collide with the player. Yes, so as you can see, it still prints the collision. So the second thing we have to do is set the bit mask for the collider node also. So I'm just going to copy, and here after this line I'm just going to paste. So the collider node that set from collider mask to bitmask32.bit1. So here we set the set into collider mask, and here we are setting the set from collider mask. And now if I run it, now it says no collision. So now this part is executing, so there is no collision detected. Okay. So as I said, this queue that get entries returns a list of collisions. So the proper way, instead of doing here the if statement, the proper way should be just loop through these entries. And we can do this by, but before I'm going to do, I'm just going to remove this else part, just to show you how the collision works. So now, if I move, let's say, the player character into this platform, it will say that it detects a collision. And now it's no collision, collision, collision. If I move the player a little bit lower, let's say, I don't know, 6 in the position vector. Okay, and now let's see, it collides with this platform, and now the player is between these two platforms, as you can see. And if I go here, it is still above this lower platform. As you can see, here is a gap. I'm just going to move the player a little bit more down, so let's say 4 units on the z-axis. So now let's see, now it collides with this platform. Let's move the player a little bit here. Now the collision is stopped, and it collides also with this platform. And let's move it here. And as you can see, it also collides with the third platform. So as I said, the proper way to actually check for the collision queue is by doing with a for loop. So I'm just going to comment out this if statement and just replace it with a for loop. So although I don't need this if statement, I'm going to delete it completely. So here we are going to loop through for entry in self.queue that get entries, and to actually get the node path or the impulse, or the not the impulse but the into node path, we can do this. So I'm just going to name it enp or into node path. So enp equals entry, which is a collision entry object that get into node path. So the into node path is the node path which we are colliding with, and get its position according to the renderer. And this will return a L point free, so a vector free or a point free object. And for now I'm just going to set the position vector. So the self.position vector that z to the impulse into node path that z. So let me see if it works or not. So I'm just going to add back to the self.acceleration the gravity, so self.gravity, so which will pull down the character in every frame. And also I'm just going to move the character a little bit higher, so set the position back to on the z to 30 units. And now let's see if it works or not. So, oops, and as you can see now the floor, the character is on the floor, so it stopped at the floor. So once again, and yes. So, yeah, in each frame, so we are actually changing in each frame the position by the velocity index acceleration. And here, when a collision is detected, we are setting the position vector z-axis to the into node path z-axis. Okay, so in this section we are going to implement the jumping. So for now we just have, I'm just going to switch it to platformer. So now we just have a movement to right and left, and if I press the up arrow, nothing happens. So that is what we are going to implement now. So the first thing what we need to do is actually detect the up arrow key press, and we can do this by here. So here are the keyboard input events, just by adding the self.accept method, giving it the up arrow, and I'm going to give it the self.jump method, which is not yet created. So I'm just going to create here before the update a new method called jump, and I'm just going to give it for now a pass, because we still need some jump variables, and I'm just going to copy it. So after this line I'm just going to create the jump variables. For now I'm just going to create one jump variable which is jumping, which is a boolean, and it starts with false. So when the character is in the air, it means it is jumping. When it is on the floor, so is jumping will be true, and when the character is in the floor or on the platforms, this variable is jumping will be false. So okay, so when the jump happens, I'm just going to set this variable to true. So is jumping will be equals to true. And here in this for entry in self.queue.get entries, here I'm just going to ask one thing. So if not self.isJumping, so if the character is not jumping, then I'm going to set the position.z to the into notepad.z, and else self.isJumping will be set back to false. Okay, let me show you. So here I added this keyboard input event, so every time when we press the up arrow, this jump method will be run, and the jump method will set the isJumping variable to true. And here in the entries for loop, we are always going to ask if not self is jumping, so when it is not jumping, it means it is on the floor or it is on the platform or platforms. We are going to set its position to into notepad z-axis, position z into notepad z. And else, if the character is jumping, then we are going to set the isJumping back to false. So let me try it. So okay, I just forgot to add one more line, which is setting in the jump method, setting the velocity z to the jump force. So I'm just going to copy it from my second monitor, and self.velocity z, so the vertical axis will be equal to the jump force, and the jump force I created earlier, it is set to 1.2. So let me see it, if it is working or not. And as you can see, now our character can jump and also land on the platforms. So, but there is still a few problems. One problem is that if I jump on the platform and wait for a few seconds, and as you can see now, the character just, because we are still accumulating the velocity, so the velocity on the z-axis becomes that so much high that I'm just going to show you. As you can see, it falls so fast from the platform. That is absolutely not normal. So every time when the character is on a platform or on the floor, we are going to set back the velocity z-axis to 0. So if the character is not jumping, it means it is on the platform. In this case, I'm just going to set the velocity.z equal to 0, and I added here a comment to prevent fast falling from platforms. So now if I try it, no matter how long I am with the character on the platform, it still will fall with the normal speed. Okay, the next thing what we are going to solve is if we jump through the platform, as you can see, the character just snaps to the platform. It doesn't jump through, but it jumps through, but as soon as it gets on top of the platform, it just snaps. Okay, and for this we are going to add one more if condition here, and this will be, I'm just going to copy it because I have some comments here also. So if the self.velocity.z is less than 0, it means we are falling, Yes, we are falling. So in this case, we are going to prevent, so this if statement prevents snapping to the top of the platforms. So the second if statement, I'm just going to move it, tab it into the body of this if statement. So let me try it out. So now if I jump through the platform, as you can see, it jumps through and it lands on the top of the platform. Let me try it with this one. Okay. And in the next section, I'm just going to add the double jump. So now if I on the air, I can jump in as many times as I want. So I just have to always press the up arrow. So I'm just going to prevent this behavior so that it will do double jumping and then it will fall down. Okay, so in this section, as I said, we are going to add the double jump functionality, because now our character can jump as many as we want. So we will prevent this behavior. So to the jump variables, I'm going to add two more variables. One will be the is on floor, which will be also a boolean, and this will be set by default to true. And the self.jump count will be set to 0. So here in the jump method, I'm going to ask every time if this jump method is run, I'm going to ask if self.isOnFloor. So if isOnFloor is true, then execute these lines. So if is jumping will be set to true, and isOnFloor will be set to false. So if isOnFloor is true, then is jumping. So it means we can only jump when the character is on floor. And we press the up arrow, the is jumping variable will be set to true, the is on floor variable will be set to false, and we will set the velocity.z to the jump force. And we are also going to increment the jump count by 1. Okay, the next thing inside this if condition, I'm just going to copy and paste a nested if condition. So if the jump count equals 2, then is jumping will be set back to false. So here we are setting it to true, but if the jump count is 2, we are going to set the jumping back to false. And is on floor, we are going to set it back to true and also reset the jump count to 0. So, okay, the next move will be actually here in the for entry in self.queue.getEntries loop. I'm just going to add after this self.velocity.z, I'm going to set the is on floor to true. So if not jumping, then do this, and set the is on floor to true. And I think this is enough, so let me see it. So now if I'm jumping and if I press the up arrow twice, it will do double jump. If I press it more times, nothing happens. It only can do double jumping. Even when we are going to like this. But we are not cannot do triple or quadruple jumps or something like that. We only can do double jumps. So one more time, we need here under the jump variables 2 more, which one is the is on floor, which will be set by default to true, and we also need a jump count, which will be set to 0. And here, when we press the up arrow, this jump method will be run. So, and we are always going to check if the character is on floor. And if this is true, then we are going to set the jumping to true, is on floor to false, the jump velocity z to jump force, and also increment the jump count. And also we are going to check if the jump count is 2. We are going to set back the is jumping to false, is on floor to true, and set the jump count to 0. And here we are only changed one thing, so if not jumping, which means is the character is on the floor, then we are also going to set here is on floor equals true. So the very last thing we are going to implement to this platformer prototype game is actually camera follow. So the camera will follow the character movement, which can be easily done just by one line. So of course we are going to do this in the update method. And here we are setting the player's position, and after this line I'm also going to set the camera's position. So self.cam.setX, so on the x-axis to self.position.x. So only with this one line we can move the camera with the character. And let me see, so now the character should be always centered in the camera's view. Of course you can add all sorts of, I don't know, like smooth movement so that the camera doesn't start immediately follow the character, but I leave it to you. As I said in the beginning of this video, I couldn't get my head around one thing, which maybe I will appreciate your help if you want to contribute. So how to solve that the character actually doesn't jumps through the platforms, so it should just collide from the bottom of the platform and fall back to the floor. I just don't had enough time to actually solve this problem. Maybe if someone from you can solve it, I will do a second video just and give you a credit or something like that. If not, I don't care. So, and at the end, I'm just going to inform you that all of this code will be uploaded to my GitHub page. But before I upload, I will add some more comments to this code. And the link to that GitHub page will be added to the video description. So you can download it and you can modify the code. You can do your own game based on this platformer prototype. I will probably add something like a GPL or MIT license for this project. And yes, that's all what I wanted to show you in this video. So thanks for watching and have a nice day.